Hello my dear students, in this video lecture I am going to discuss Introduction to Communication System, Elements of Communication and Amplitude Modulation. Transfer of information from one place to another place is called communication. This is the general definition of a communication. Transmission, reception and processing of information between two or more locations using electronic circuits is called electronic communication. The original source information may be in the analog form or it may be in the digital form. Time varying voltages or currents is called analog signal. Voltages or currents that changes in discrete steps is called digital signal. Baseband signal is nothing but original information signal or the message signal or the modulating signal. These four terminologies are one and the same. Putting the original signal directly into the medium in the sense the channel, communication channel, is called baseband transmission. So baseband transmission is suitable for small distance in the range of within a few meters, but it is not suitable for a long distance like kilometers together. Some of the examples of baseband transmission is a classroom scenario, a teacher teaching and students are listening. It is a baseband transmission. Is a best example for this type of transmission. Electronics elements of communication. It mainly consisting of three subsections like transmitter, channel, and the receiver. So the information signal is given to the transmitter. The main function of the transmitter is to modify the information signal so that it is ready to transmit over a channel. So this modulation is done by a circuit called a modulator, and this process is called as the modulation. The resulted wave after modulation is called a modulated wave or the radio wave. Then this modulated wave is put into the channel. The channel may be wire or wireless. Example for wire communication are twisted telephone cables, optical fiber cables, coaxial cables, etc. Wireless means there is no connection between the transmitter and receiver. The information or the signal is transmitted through air or vacuum. Again, at the receiver side, the original information signal is get separated from the modulated wave. This process is called as demodulation, and this is done by an electronic circuit called a demodulator. It is exactly the reverse process of a modulator. So when the information is transmitting from transmitter to receiver through a channel, there may be a chances of noise get added into the signal. Again, there are different types of noise like external noise, internal noise. External noise originates external to the source. Internal noise originates within the source. External noise is further classified into three groups like atmospheric noise, extraterrestrial noise, and man-made noise. Atmospheric noise is due to lightning discharge and other electrical disturbance in the atmosphere. Extraterrestrial noise originates from sun called solar noise and from other distant stars called cosmic noise. Man-made noise are automobile ignition, aircraft ignition, electric welding, leakage from high voltage line, etc. Internal noise is due to various electronic components used in the communication system and is internal to the system. Examples are short noise, thermal noise, white noise, low frequency noise, high frequency noise, etc. Next is the modulation. As I mentioned in the previous slide, before transmitting the information signal, it should be modified so that the signal is transmitted over a long distance. So this is done by using an additional signal called a carrier signal. Then the modulation is defined as the process by which some characteristics of a carrier like amplitude or frequency or phase is varied in according with the baseband signal. So this is the baseband signal. Baseband signal is nothing but the original information signal, which is denoted as m of t. T represent it is in the time domain. This is the carrier signal whose frequency is very much higher than the information signal frequency. The range of information signal frequency is 20 to 20 kilohertz. If amplitude varies in accordance with the change in the information signal, then it is called as an amplitude modulated wave. This is the amplitude modulated wave, where amplitude of the carrier is varying with the change in the information signal. If frequency varies in, in accordance with the change in the information signal, then it is called as a frequency modulation. If phase changes with change in the information signal, then it is called as phase modulation. There are few advantages of modulation like it minimizes the noise, signal can be transmitted over a long distance, it minimizes the height of the antenna, multiplexing is possible. Multiplexing means more than one information signal can be transmitted over a single channel. So these are some of the advantages of modulation. This is the spectrum of amplitude modulated wave. It contains three components. First one is the carrier with a frequency Fc. Fc indicates the carrier signal frequency. This is the upper side band whose frequency is Fc plus Fm. Here Fm is the frequency of the message signal. Another component is lower side band whose frequency is Fc minus Fm. The difference of Fc plus Fm and Fc minus Fm gives the bandwidth of the spectrum. So equation 1 is the time domain equation of amplitude modulated wave, where Ec is the amplitude of carrier in volts, mu is the modulation index, omega m is the modulating frequency in radians per second, omega c is the carrier frequency in radians per second. And modulation index is given by two equations, that is equation number 2 and 3, where Em is the amplitude of modulating signal in voltage, E maximum is the maximum amplitude of amplitude modulated wave, E minimum is the minimum amplitude of amplitude modulated wave. Expanding equation 1, further simplification, equation 4 is obtained. From this, it is observed that there are three components like the unmodulated carrier, which does not contain any information. This is the lower side band, and this is the upper side band. These side bands contains the information signal or information components. Then the total power consumed by the AM is given by the sum of the carrier power, upper sideband power and the lower sideband power. The carrier power is given by EC square divided by 2R. Upper sideband and lower sideband power is given by EC square mu square divided by 8R, where R is the load resistance. By assuming R is equal to 1 ohm, finally we get the equation total power is equal to the carrier power all multiplied by 1 plus mu square divided by 2. This equation is the relationship between total power, carrier power and the modulation index. If you consider mu is equal to 1, it is nothing but 100% modulation, then the total power is equal to 1.5 times of the carrier power. For example, if 1 watt is consumed by the carrier, then the total power required to transmit the amplitude modulated wave is 1.5 watt. Further, it is shown that carrier power is equal to 66.6% of the total power, which means 66.6% of power is required to transmit the carrier signal, and rest of the power, it is 33.4% is required to transmit the sidebands. That means sidebands consume less power compared to the carrier. So this is the assignment for this video section. 4 assignments are given. I suggest all the students complete this assignment, write the answer for this. It is very much useful for your examination. I hope you enjoyed this video. Have a nice day. Bye bye. Take care.